So very nice that you all came here today. I'm quite excited myself to do my very first workshop on mushroom cultivation with you guys. I want to introduce myself. I'm Daniel. I'm from Germany. I'm a designer, and I'm doing a residency here at Kitchen Budapest during the last 3 months, in which I worked on this workshop and on some research with mushrooms. First, about my background, how I started with mushrooms. It all started here at Mycelium. It's an institution in Amsterdam, an art institution which mainly works with bio art and bio design, bio designers. And 2.5 years ago, its focus was on fungi and mushrooms and everything that is related with. This guy, Anthony, a biotechnician, a PhD in mushroom, whatever, introduced me to the topic, told me everything I needed to know to start off, and yeah, and I kind of give it on to you today. We did some workshops there, we did material research, we worked together with artists, and this is a picture of a workshop of a oyster mushroom cultivation workshop as we do today. A little bit more professional, not that DIY as we do it today. But anyway, I wanted to share this with you. And this was what we showed to the people. Some samples, some magic mushrooms, some candles made out of mushroom materials, you know, everything we had at that time. And this kind of, well, pushed me in a direction as a designer myself. I was still a student at that time and did a lot of projects, or I tried to incorporate this concept of mushroom cultivation in my projects. So I not only worked with mushrooms, but living organisms in general, with algae, with bacteria, with kombucha, for example. But here, these are the projects based on mushrooms. This is, for example, a material which is glued together by a mushroom. Up there, you see bricks compressed out of organic waste, so coffee, or napkins, and then grown together with a mushroom, harvesting the nutrients from it. And those were all concepts which only could work out because I knew about the organism. And I think it's nice, it's worth sharing these concepts, and this is what I do today with you at Kitchen Budapest. It's one of the samples which emerged here. And now I would like to get to know you maybe in 2 or 3 sentences. What's your background? What do you expect today? Or what's your interest in fungi today? This is how we're going to proceed in the workshop. First, all the basics we need to know about mushrooms so that we can talk about it. Mushroom ecology, I would say. Then some theories related to it, and in the middle of the workshop there's some projects I want to show you which are about materials, mushroom-based materials. And in the 4th step we get our hands on, of course. That's why the gloves are there and the boxes and the nice looking grey stuff. Please don't open it during the workshop, we will get to that later. And in the end there's time for questions. But please, if there's something unclear, just shout or raise your hand. I'm open to questions the whole workshop, please. So let's talk about mushrooms. Mushrooms are organisms with a huge potential. Some people say they might even save the world. So, some history. 1.3 billion years ago they came to land as the first living organisms, or organisms on land. Several 100 million years before plants actually. And there is a common ancestor of animals and fungi, which is closer related than animals and so we are closer related to fungi than to plants. That is what I want to say, because we share a common ancestor some 100 million years ago. And this is a photo from the 80s, some guy finding a fossil which is actually 9 meters long, 1 meter in diameter. And it's a 400 million year old mushroom, or at least an ancestor of mushrooms. At that time, the biggest organism on land, 10 times bigger than any plant. I think that's quite cool. Of course, nowadays there's no mushrooms like that. Unfortunately, it would be super cool, I guess. You could have a feast from it. So what is a mushroom? What we call a mushroom, what we get in the supermarket or in the farmer's market as a mushroom, is actually just the reproductive fruiting body of the whole organism. What you see here on the image is the fruiting body there, and the actual mushroom is up there. So it's just a reproductive spore-producing fruiting body of the thing, which is kind of clarified by this image. It's the sexual organ of the whole fungus, which is growing underground. So the fruiting body, which we call mushroom, is just a small percentage of the whole organism. And it's also just popping up in several times. Usually it's growing underground. And this underground fungi is made out of thin filaments, of a web of thin filaments, interconnected filaments, which are called mycelium, as you see down here. That's how you write it. And I think also that's why all the mushroom-related things are starting with myco, like mycology, which is the science of mushrooms, I think, or fungi. Mycelium, as I said, is made of tiny, thin filaments, which you can see here, I think. And I also have a sample here, which you can hand around, where you see the mycelium growing through a substrate. And it's kind of clear what I mean when I say it's filament, it's interconnected, but it's also pretty cool. This is how mycelium grows. It starts growing at one point, usually where a spore settles, and it grows in a three-dimensional sphere, so in all directions at the same time, with quite some speed also, not like this, but maybe a centimeter per day or something like that. This is how it looks under a microscope. These filaments are super thin. Some are just one cell wall thick.
But they connect to each other?
They connect to each other. They grow in directions and then grow together again and merge in a way. Still are the same organism. Also, if two spores grow together, it's still the same organism in a way.
And if they are different spores?
If there are different spores, they will try to overpower each other. So if there are different species, for example, they try to overpower each other. But if they are from the same species, as far as I know, or the same strain, so the same genetical master culture, then they like each other and merge. This tiny web of filaments is the part of the fungi which takes in nutrients. It digests all kind of organic substances by using enzymatic fluids, so fluids which break down compounds. And they take it in this filament, which is super thin, super tiny, has a huge surface in a way. And through these filaments, these nutrients are getting transported through the whole organism. You have to imagine the whole organism can become huge. You don't see it, it's underground. The biggest known mushroom is 2,000 acres big, somewhere in America. I don't really know how big 2,000 acres are, but it sounds pretty cool and pretty impressive, I think. So this is how it looks. Mushrooms, fungi are in most environments, most landscapes, especially in the forests. You find them everywhere. If you pick up a rotting wood, usually it's white underneath, and that's some mycelium from a mushroom. It holds together the whole humus, soil of the earth, but also produces it by digesting all kinds of organics. So here is again the whole thing. At the right conditions, the mycelium creates a fruiting body, which we harvest, which we like, which we eat, and so on. And here, question? No. Here I want to simplify the process which I talked about now again. So a spore settles here in a beneficial environment up there. It starts spreading underground, it starts eating, it starts taking in nutrients, And at some point, at the right conditions, it starts producing a baby mushroom, which then grows bigger and bigger until it's big enough to produce spores again, and restart the cycle, start a new generation in a way. And this cycle is split up in two stages, in the reproductive stage and the vegetative stage. The vegetative stage basically describes the mushroom growing underground, taking in nutrients, getting stronger, preparing for reproduction. And this reproductive stage starts when all the nutrients are running out, for example, when the weather is getting bad, when the mushroom feels that its time is running out, that it needs to reproduce now to survive, that it needs to find a new niche, then it starts producing fruiting bodies. So the vegetative stage is commonly known as spawn run, as the mycelium is running underground. So keep that in mind. Spawn run is what I will refer to as vegetative stage later. And the reproductive stage is just called fruiting. I think that's obvious why. Yes, this is how spawn run looks. So vegetative stage. Many starting points, usually where the spores settle, and growing in all directions, merging together, and in the end creating a block of mycelium, just like this. This is actually the same bag, just 2 weeks later. The whole organism has grown through the bag. This is just one brick now, one brick of mycelium, no loose organic substrate anymore, it's just interconnected fungi. And you see it also grew up here on the plastic bag as it runs out of nutrients down here. There's nothing more to digest for it. So it's searching for new niches, and at some point soon, I think, it will try to reproduce. Just hand it around, it's pretty cool, you can't hurt it.
Did it go through the plastic?
It's not going through the plastic, but it's kind of growing on the plastic, or at least on the moisture of the plastic. I think that's kind of impressive because somewhere it needs to get its nutrients.
Do you add any water to it, or just it is as this?
This is as it is since the date is written on it, since 23rd of March, which is now 3 weeks. No, 4 weeks. Pretty sure 4 weeks. It was growing in the dark, so underground in a way, in a warm environment. To become like this. This is a time lapse of how it grows in the dark. You see now it has all the nutrients, and now it starts growing up outside. See it again. So it really grows through the whole substrate, connects everything, gets all the nutrients, preparing for reproduction. Reproduction then looks like this. It starts building a lot of tiny baby mushrooms, which are called Primordia, but I will just call them baby mushrooms as it's easier. These baby mushrooms kind of fight against each other for nutrients. In the end, only one cluster of baby mushrooms will make it. Will grow bigger, just like these, and then finally become fruiting bodies which reproduce through spores. These can pop up pretty strong and even break asphalt. Some strains, some species of mushrooms, which I also think is quite cool. This is the mushroom we are going to work with today. Oyster mushroom, or Pleurotus austriatus in German, or Pleurotus ostritus in English, I think. I forgot how it is called in Hungarian, but I'm sure you all know it. Yes, Laskagomba. You can buy it at Aldi, super cheap. I like it. Probably you like it as well. It's one of the most popular edible mushrooms and can be found everywhere in the world, as it is super adaptable to all kinds of environments. It basically grows on anything that is organic, and thus is also the most common mushroom for artificial farming mushroom. artificial cultivation. In nature, it grows on dead trees usually, and it grows between spring and between late fall and spring. So right now it also is growing, but also in winter it can grow, which also is quite cool. Again, you see, I'm a big fan of this kind of mushroom. It belongs to the group of saprophytes. These kind of mushrooms, saprophytes, break down organic matter. That's basically the easy description for them. They break down organic compounds which cannot be broken down by bacteria or other organisms. So like it's called lignin, this compound, which is some kind of part of rotten wood. For example, it's part of the plant cells in every plant, and can only be broken down by mushrooms and a few other organisms. So they are quite important for ecosystems. And here you see the process of wood chips, how they are usually when they are cultivated by fungi. So they are grown over fungi like this bag. They are fully cultivated. And afterwards it takes not much time for them to fall apart. So mushrooms are super fast decomposers. As I said before, mushrooms, oyster mushrooms are famous for cultivation. They are easy to cultivate, and this is how I would say, semi-professional farm looks. It's not that big, but it's still quite impressive. These mushroom bricks are something like that. And yeah, I want to walk you through now through the cultivation process, which we are going to repeat later in a simplified form as well. First of all, what you need to start off the growth in cultivation is not a spore. I said before, mushrooms reproduce by spores, but still this takes quite a long time. We need to work sterile if we work with spores. There's many other spores in the air, and so we work with spawn. Spawn is an organic material which is easy to break down, usually some kind of grain, and this material is cultivated by fungi. So it started its vegetative stage, its spawn run already, and this speeds up the whole process. I can take a hand of this grain, make it really small, and seed it then in a substrate, mix it well, and have many starting points for the fungi to grow. Is that clear? Yes. I give you that bag, it's quite cool, it's closed, nothing can happen. I got it from a mushroom farm first year. It's an old guy, I have it written on my handout, where you can get this spawn if you're interested in. It's very cheap. And the easiest way and the most common way for mushroom cultivation. Yes, as I said, there's a big number of starting points for the fungi to grow them, and the bigger that number of starting points is, the faster it grows through the whole substrate, and the less risky it is that there's contamination or other organisms growing with it, the faster it grows. But spawn can basically be any kind of organic substrate which is cultivated by a mushroom. So here you see I cut off the stems of the mushrooms. I only ate the caps, and I just put the stems in a jar, in a glass jar, in a dark place for 1 week, and they went back to vegetative stage. So they went back to spawn run, and at that stage you can just seed them in substrate. So that's basically the easiest way how you can reproduce mushrooms at home, which you buy at Aldi, for example, or at Spar or whatever. You just put them in a dark place, in a jar, close the lid for 1 week, and then it looks like this, and it wants to reproduce. And that's pretty cool and super easy. Now that we know what spawn is, we need to know what we're going to seed it in. The substrate, it's the nutritious habitat in which the fungi is growing later, from which it gets its nutrients. As I said before, it's organic compounds. Today we will work with hardwood chips from beech trees. Then we will use some sawdust, which I got in a wood workshop around the corner. Coffee waste from the restaurant next door, with some gypsum from the art supply shop, and with some wheat bran, which is basically the shells of wheat, I think, from the substitute which you can put in your muesli. It's super cheap, but mushrooms love it. So this is what we're going to work with as a basic recipe. I also wrote it down on your handout for you at home. But there's space for experimentation here. This is an experiment when I inoculated a toilet paper roll, and it also worked out pretty well. These mushrooms didn't grow so big as they dried out, actually, because the Easter holidays kind of made it impossible to keep them wet, keep them moist. But it's just toilet paper, it's paper-based substrate, and this shows you can try it on anything. I know people who grew mushrooms on their shoes, on their sofa, on books, for example, on magazines, whatever. As long as it is organic, you can try it. Give it a try, yes. This is when the mushroom substrate, when the substrate is fully grown through. We've seen it before. Here I want to emphasize that the mushroom incorporates all of the nutrients in the substrate. So that means if you want to eat the mushroom afterwards, you need to take care what is in the substrate. So you shouldn't use, for example, if you work with straw, for example, don't use straw which is treated with pesticides, as the mushroom will incorporate these pesticides to some degree as well. Or if you want to work with substances like plastic or oil, which is also partly digested by a mushroom, don't eat it afterwards, because the mushroom takes in all the toxics, all the heavy metals. That's also the reason why I'm from Bavaria, southern part of Germany. There they tell us we shouldn't eat mushrooms too often from the forest because of the radiation which is still around, especially caught up by mushrooms, because we will eat that radiation as well. And what I want to say is the mushroom is what it eats, and take care what you feed it with. So. This is the cultivation cycle I talked you through. Right now we start with spawn, add it to substrate, which is then inoculated substrate, and wait for the fungi to fruit. Basically, it's super easy. These fruiting bodies we can use as spawn. Afterwards, we can cut off the stems, or we use the cultivated substrate for this stuff again as spawn to seed the mushroom in new substrate. So that's how mushroom cultivation works, also in professional levels usually. The artificial environment we need to fake here is the environment of spring for the mushroom in real life, so in nature. We kind of have to fake the underground growth, so we put it in a dark environment because it's under the surface. We put it in the paper box, for example, or in the basement. And it also likes some heat, as in spring it's getting warmer, the floor is going to heat up, so it likes temperatures around 25 degrees. And it likes to be left alone, so it doesn't want to be moved, it doesn't want to be attracted to light, it doesn't want to be beaten or something like that. It just wants to grow slowly under the surface, and that's what we fake here. This spawn run usually takes about 3 weeks, 2 or 3 weeks to finish, and then it's ready for the next stage, for the fruiting stage. And for this fruiting stage we need to change the weather conditions. We have to fake autumn here. So we make a few really shitty days, like the last 2 days, for example. Cold weather, it's raining a lot. There's maybe wind going on, so we put it in daylight. We give it a cold shock for 24 hours. That means we put it outside for 24 hours. We put it to lower temperature, open the bag, daylight, as I said before, so that's quite simple. Daylight, fresh air, and colder temperatures. Then the mushroom switches stages as it feels it is in danger. It needs to reproduce now. You can fake this environment pretty easily with the growth box, which you see over here. You can take a closer look later, but that's my fruiting chamber actually. Here I can maintain a high level of humidity. It gets daylight through the transparent plastic. The temperature is fine in here because it got its cold shock already, so it switched its mode already, and it is not so likely to dry out in there like my toilet paper roll. And then fruiting starts. This is the toilet paper roll, and at that point it was Easter and the mushrooms dried in. But this is how it should look like, and I think it's quite easy to say. If you watch the substrate, it's kind of moving, it's breathing, I would say, but it's always when I spray water on it, it's soaking up the water and using that for the reproduction of the fungi. The fruiting bodies are 90% water, so it's really important to keep up the humidity, otherwise your mushrooms are going to dry in very easily. One last point I want to emphasize is contamination. That's basically the biggest enemy a mushroom grower has to fight with, as this substrate we are creating later is very nutritious. There's coffee inside, there's organics inside, so molds can grow, other organisms like to grow in there as well. So we have to kind of calculate with contamination. It can happen, and it's then looking like this usually. It's then looking like this usually. It's usually green mold. Most of the time it's green mold. It's producing these green spores, and if you see that on your mushroom, then it's safe, but you have to put it outside because these spores are harmful for yourself. But they are not harmful for your garden, for example, for the outside garden, so you can maybe plant them in the earth and wait for nature to do the job and see if it grows outside. Actually, I did that a few weeks ago outside in our garden. There's some fruiting bodies coming up right now. You can maybe take a look later if you're interested. But that's how you can cope with it. Anyway, we're working with living organisms. We're faking complex natural processes, so it's not uncommon that this is happening. Especially with the technique we're going to do today, which is not sterile, it can happen. And this happens even to factories, even to professional growers. Even skilled growers can or have to cope with contamination from time to time, and then just try it again. So what I said, no, I didn't say it yet, I say now. We have to, the only measure we can take is preventive hygiene. So we have to clean ourselves, we have to clean our working environment as much as possible, and just try to not directly breathe in the fungi, for example. Work quick, don't attract it to any sources of contamination too much. Don't work next to the trash, for example. Put on clean clothes, dry your hair, clean your hands. If possible, use some alcohol or hydrogen peroxide to sterilize the working environment. This is ideal. I guess this was at Mycelium. We had an overpressure room with a filtration system. We had a sterile substrate. We had full body suits, but this also was kind of show. In my experience, it's not always necessary. One thing we could possibly do is heat treatment. So we could work with sterilization. That means killing all the competing microorganisms, all the pathogens growing in the substrate before introducing the mushroom to the substrate. That happens through heat, 120 degrees so with the overpressure cooker you can reach that for half an hour, I think. And you can learn about that, you can read about that on the further reading which I provide you on the handout as well. But today we will not work with that. As we work with oyster mushroom, a relatively aggressive mushroom, a fast-growing mushroom, so there's still a high rate of success without contamination with working with oyster mushrooms. Now that you know the basics, you can understand what I'm talking about. This is Paul Stamets. He's kind of a celebrity in the mushroom communities. Yeah. He wrote a lot of books and also some good ones. This one is a very good one. Take a look at it later. I can recommend it. Most of the things I talk about today are also in there. Even more. He started out as a mushroom enthusiast some decades ago and was this crazy guy who bought a little house in a forest in America somewhere. But over time he got a lot of patents, he got accepted by scientists, he's working now together with PhDs and universities and researches quite a lot how mushrooms can help remediate an environment. That means how can they be used to help environment to recover from catastrophe, from toxic substances, from humans, whatever. Yes, he also highlights in this book one of the super cool properties of mushrooms, which is called mycorrhiza. This is a symbiotic relationship. Mushrooms, fungi fungi have this symbiotic relationship with most of plants on our planet. 90% of all green plants on the planet are connected to a fungi through their roots. So the fungi attaches, like you see here, to the root of this tiny plant and helps it soak up water. And in return, the plant gives carbohydrates and nutrients to the fungi. That is pretty cool and pretty important for the plants as well, as it helps them to grow faster, to compete better against their common plants, against their competitors, I would say. This looks then something like this, and as I said, 90% of all plants are connected by fungi. And as I said before, fungi can grow to a huge, through a huge area. They can become very big. And this connection of plants is then provided through the fungi. So plants are kind of connected to each other by this mycelial network, which transports nutrients, which transports substances and enzymes. And thereby, as you see on this picture, it really is one fungi which connects plants of several roots of several plants, and thereby these plants can communicate. Bigger plants can help smaller plants to grow faster. They can share nutrients. For example, it is proven that big trees help their tinier trees from the same species to grow, as they don't have so much sunlight, the smaller ones. They help them out with some nutrients. And also they can send toxins or stuff like that to fight against unwanted organisms who enter their environment. Scientists call this the wood wide web, because it's basically something like the internet, if you think about it. It's an interconnection of many organisms of different species, even different kinds, because you also need to think about that the fungi is also connected to other microorganisms, to other insects or whatever that are in its environment and maybe working together. So all these substances are getting exchanged, and the roots are kind of linked through the fungal network. This fungal network provides a easy and quick communication, and I think this is quite interesting, as scientists weren't even aware of this since until the 50s, I think. In the 50s they first discovered this symbiotic relationship as so important, and since then you can buy fertilizers, for example, which basically plant fungi in your garden, and thereby you make your grass grow faster, grow better. Yeah, I just bought my parents a fertilizer like this to try this out for me, but theory is there and I want to see this. Paul Stamets promotes the mushrooms as a good measure for myco-restoration, mycoremediation, as I said before. As the fungi has many properties which are beneficial to an environment by connecting it or also being capable to repair it. It is, this is again the Mycelium network, and you can really imagine it can be a web which filters out substances or bacteria. It has enzymes which fight bacteria, it's antibiotic, so it's actually being used for microfiltration, for cleaning water from coli bacteria, for example. And as I said, it's being used for microforestry, as a fertilizer, for example. Then it can also be used as a pesticide, first attracting insects and then fighting them from inside. So it's kind of growing over the insect and then killing it, using it as a substrate, yes. And Paul Stamets holds quite a lot of patents on this, as it is an environmental friendly way to kill insects, if you could say so. But he doesn't need to use any pesticides on his cornfields, for example. This is a drop of oil which is introduced to mycelium. And the mycelium takes in the oil very much, as you see here. This is also a research done by Paul Stamets, and he said that it soaks up the yellow color. So it soaks up the substances of the oil down here and bleaches out afterward again. So it kind of breaks down the oil. It still takes in the heavy metals, as I said before, so you shouldn't eat mushrooms from that experiment, but still it breaks down the oil to some amount to its main substances. And this is actually being done that, this is called mycoremediation. This is being done for environments which are toxic, which are poisoned, to remediate them and allow other plants to grow on them. Mushrooms hold a lot of medicinal properties, especially this mushroom, which is called reishi, or fungi of the gods, or divine mushroom. It's being used in ancient China for almost 4,000 years now, and has a lot of nice properties against bacteria, against heart disease, high blood pressure, cholesterol, it's called in English, or some say it's anti-cancerous, or it's working anti-cancerous. It has some really good properties. Any mushroom has some good has good properties. Also, oyster mushrooms provide a big amount of proteins, so that's why it's pretty good to eat them. Now, this I shouldn't miss out on this topic on a presentation about mushrooms. I think magic mushrooms, which you see here, are contain naturally occurring psychedelic compounds, which is called psilocybin. There's so far 200 species known which hold this compound, and yeah, it's proven that humans use these mushrooms for a long time already. But in most countries nowadays it's prohibited by law, unless some countries which found some gaps in the law, but almost no country allows them. And they have mind-altering effects. That's how they grow. That's how most of them grow naturally on some shit. Yeah, they have mind-altering effects similar to LSD or DMT, but so you could feel some kind of euphoria, hallucinations, spiritual experiences, but of course the trip can turn out bad as well. You can have nausea or panic attacks, just to warn you guys. The intensity can vary due to, depending on the species, depending on the amount you take. And it's going to take 2 to 6 hours until this trip is over. Why I tell you this? Because of this guy, which is called Terence McKenna, who is kind of an ambassador for the psychedelic mushrooms. or at least he was. He died in 2001 already, and he's another celebrity in the community, some other kind of community basically. He came up with a lot of theories which are also very much influenced by the use of psychedelic drugs. One of them is the mushroom from space theory. He said mushrooms didn't emerge naturally on Earth. They came here with an asteroid, or they were sent by another civilization to seed genes on habitable planets. So that was his theory on how life came to Earth, basically. Of course, this is not entirely proven. No, it's not. But he came up with another theory which kind of made him famous as well, the stoned ape theory. He came up with that about 25 years ago, and it states that our ancestors, when they came down from the trees because of climate change or whatever, they had to find new foods which they were not used to, and part of that were psychedelic mushrooms. And these psychedelic mushrooms and their effects helped them to develop some consciousness, to develop language, to have some evolutionary advantages against other animals at that time. And that kind of made him famous. Still there's a lot of people who talk about this. Scientists don't really believe him, as he came up with so many crazy theories that nobody really takes him serious from that area. But anyway, I didn't want to, I wanted to tell you about this because I think there's some really interesting talks on YouTube, really interesting books you can read about it if you're into that. Mushroom-based alternatives, material alternatives. This is my favorite topic now, as this is also what I'm working on mostly. These organisms. They can be grown in any shape. I have some samples here, which I also would like to give around. Please be a little careful. Just prototypes, they might break. They can be grown in any shape, and thus this gives the opportunity to create new materials which are not being used so far. And use them in a professional or in some big scale way as well. So you could make molds for mushrooms to grow in shapes like this and make a building out of it.
Excuse me.
Yes.
If it dries, can you just water them and will they grow or not?
No, if it dries, it dies. This is dried substrate and thus it's dead. If I put water on it, it will. So there's no spores. Spores just come when the fruiting bodies come, and I don't want the fruiting bodies to come, as it would take a lot of nutrients out of the substrate, and I want to keep the nutrients in there to maintain the strength. And these materials it's very important that there's no spores on them, that they don't start growing. If you, for example, package your computer in it, you don't want to have mushrooms growing in it. But yes, so there was a guy who built a building out of dried mycelium. This is again the lamp, which uses properties of these materials. That is, it's not easy to inflame it. It's actually self-extinguishing and fire resistant, so you can use it in places where it's getting hot, for example. And now I want to show you the short promotion video of Mycoworks, a San Francisco-based company which researches these properties and tries to come up with new materials. So, watch. So, endless possibilities. And this is actually being researched and funded by big companies already. IKEA, for example, and Dell Computers are researching this. And this was a advertisement clip from Mazda, the car company. But also NASA researches it, so they actually want to make panels for spaceships out of mushrooms, which sounds super crazy, but it's possible. And this Mycoworks company, which became famous with this conceptual piece of art, which is a 3D printed chair filled with substrate and then fruiting. They started doing serious work, researching materials and properties as they showed in the video. And currently they're working on some leather alternative, which they say is the same as leather, has the same properties, looks almost the same, and is not animal based. So let's see what comes out there. I like that very much. Another company, which my friend Anthony now, from the beginning, the guy with the mushrooms who showed me everything, he's working there right now. It's a New York-based company which wants to replace styrofoam. Yeah, as you hear from the music already, it's all really visionary. But it's happening. These videos are more than 2 or 3 years old. As I said, IKEA and Dell are working together with them, actually. So Dell Computers already promotes their packaging material in some way. So, the future packaging material, of course. But I think that's also why this workshop today is pretty cool. It's coming into the awareness of people, what is possible with this material. And of course, there's also some local businesses popping up with these opportunities with these materials. I want to present just a short video again from Rotterdam, a company which is called Rotter Swam, which is kind of a wordplay because swam is called mushroom in Dutch. But also in Vienna there's a company who basically does the same stuff. Watch. Yes, so they use they take used coffee grounds, as I did today from the restaurant. They do it in a huge scale. They have their partners. They take the coffee grounds on an everyday basis, more than 100 kilos, grow mushrooms, several kilos per week, and bring them back or sell them back to these restaurants, and thereby reduce the waste and give back something to the community, raise awareness. So that's kind of their local business plan. And exactly the same is happening in Vienna, but not so far in Budapest. So if you're up to that, still some niche.
When you collect the waste from the coffee, do you have to isolate it somehow so it doesn't get like some other...
There's no contamination.
Like quick to get some other mushroom infection. And
what they do usually is sterilize the substrate in some way. So they also use the coffee very fresh, and as the coffee is heated during the process of making coffee already, kind of pasteurizes or reduces the amount of microorganisms in the coffee already. But still they need to sterilize it in these huge amounts. You don't want contamination to happen. Yeah, that's true. Coffee grounds are very rich in nitrogen, so that's what many microorganisms love. So you need to keep it in the fridge if you want to collect
mold
it.
that tracks the seeds, it's already like, you cannot use it for mushroom cultivation or...
If it's moldy already, better not use it.
Yeah.
But if you add it day by day, for example, if you have a bucket with a spawn, with these seeds, and you add coffee day by day, it starts growing slowly, and as soon as the coffee is cultivated by the mushroom, it's unlikely to get contaminated. Because the mushroom has these enzymes, these antibiotic enzymes, which help it fight against these organisms.
If you put it in the freezer straight after using, is that a good process?
If you put the coffee, you mean? Yes, that's what I do always. I put it in the fridge to preserve it for 3 days, 4 days. Not too long as well, but better use it right away or after 1 day of collecting.
One more question. Are there any tendencies trying to make the material look nice? Because I think the biggest problem as a designer for me is that it looks super ugly, you know, and I think instinctively it looks disgusting to people because it looks something that's going to kill you. So my question is, are there any tendencies that are trying to make the Mycelium look nice or make it a good or high quality material?
Yes, you're right. It doesn't suit our image of this, which, for example, styrofoam creates, of this perfection of this flat white. This foam material, as far as I know, is not being, or maybe this was something which kind of looks nice. It's always related with some after treatment, but I know that this leather material, for example, really looks nice. But still what these companies want to promote as well is that it's natural, that it's non-chemical, that it's organic, and that kind of needs to look like this often. But you're right, I think that's the next step to happen, or that needs to happen if these materials really want to be produced in a big scale. Yeah, and that's it.